So second to the last module for this course, uh, the transport layer, module 14. So this is the part 1. So in this module, we are to cover two transport layer components, TCP and UDP. We are also to look into port numbers, okay, importance of port numbers, very important information added by TCP and UDP to our data. We look into the communication process of TCP, then other characteristics of TCP under reliability and flow control, and then we look to also into, of course, UDP. One role of the transport layer is to provide segmentation. Okay. Again, in segmentation, what will happen is our data, okay, data being transmitted, it is being broken down into pieces. Okay. Example like that. Okay. Then, so this segmentation again happens here in the transport layer. Because of this segmentation, we'll be able to run multiple applications all at the same time. Like this one in this diagram, this says that, okay, you can use your phone and at the same time you can stream a video and at the same time you can browse the web or uh, say use phone, okay, through the network. Okay, so that's how it is. Okay, so with that is we can say that the transport layer is responsible for the communication between the application running in different hosts. Managing it. Okay, managing the communication between applications running in different hosts. Okay, so another is its responsibility is to ensure reliable delivery, like with TCP, which is the agenda of this part. We'll discuss what is there in the reliable delivery as we move along in this discussion. So these are specific responsibilities of the transport layer. First, it tracks individual conversations. Just like with LVC or DHL, it has like the tracking number, okay? That like in the tracking number of LVC, DHL, you'd know if where your delivery is, right? So same thing here in the transport layer. You would know if your data has been sent or not. Okay? What the receiver will do is to send an acknowledgement. It notifies the sender if the data has been received or not. And then I mentioned a while ago that again data is being segmented. It is being broken down into smaller pieces. Okay? There's that monitoring tool where we can see those segmented data. Okay, so this segmenting data happens during sending, and then on the receiver side, these segments are being reassembled. Okay, it converts back to its original form. There are a couple of added informations in the data. As we go along, we'll define this. We'll look into this header or added information. Um, there is a number that identifies applications and in effect conversations. Like there's a port number that identifies an email or an instant messaging or a a web page. Okay, we'll look into this. We call it a port number, and we'll have a discussion on that. Okay, again, we owe it to segmentation. I mentioned this on the previous slide, and also multiplexing. Multiplexing is a concept where we combine multiple signals into a single channel. Let's say given that we have a single, say a single connection or a single channel. This channel, before legacy, it can only accept one form of data, okay, or one form of service. But nowadays, um, it can pass through simultaneous. It can pass through different forms of service through this single channel. You can have an email. Okay, let's say this is email. E, e there email, and then let's say at the same time you have your web page here, W for example, W there. Okay, so you can transmit all of these multiple signals into a single channel, single connection. This is a connection, ano, connection nyo. Ayun. And we owe it to this multiplexing. Okay? So there are two main protocols or components. There are two main components inside the transport layer, and these are these two protocols, TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. There are specific services or application layer protocol that uses TCP, and there are application layer protocols that uses UDP. You need to take note of that. IP both supports TCP and UDP. Okay? Uh, Again, transport layer is, it specifies how to transfer message between hosts, and this is responsible for managing reliable uh, delivery in a conversation. This reliability actually is a function of the TCP, but not UDP. Okay, take note of that. That's for TCP and not UDP. So now we discuss TCP. Again, TCP it stands for Transmission Control Protocol. Some of the functions of TCP is, first, it tracks data segments transmitted. Okay, example, this guy here, he sent a file to the FTP server. Okay, so again, what happens on this data is it will be segmented. Let's say we'll divide this into two. So one and then two. Okay, first, to identify that this is the first segment, there's that sequence number. There's that sequence. Say, it's literally a number. Say 1, and then this is 2. Okay? So, for example, it can send these two segments all at the same time. So, send niya. Let's say FTP receives that. Okay? So, already FTP server receives these two segments, 1 and 2. What FTP server will do is to acknowledge. It will send a piece of, say, a piece of the segment, say this one, example, this one. We call this as acknowledgement, ACK, acknowledgement. Okay? This piece of data, this piece of the data, okay, or header rather, this piece of the header, it is to be sent back to the source or sender. When the source or sender receives this piece of acknowledgement, that is an indication of the sender, that indicates that it has been received by the FTP server. Okay? So, if not, example, let's say, um, uh, this 1 and 2 segments has not been received. So, obviously, that the sender will not receive any acknowledgement, ba? It won't receive any acknowledgement. So the sender will worry, why did I not receive the acknowledgement? I should be expecting it now. Okay? So what the sender will do is to retransmit. Okay, better. I think I need to resend it again. So you will send this to this data, these two segments. Okay? The process data, which are we have here, yung two segments, again, retransmit. That's an error correction mechanism of TCP. Okay, again, keyword here is whenever data is being sent, it is being segmented, and then there's a tracking of the segments. There's one component on the tracking is the moment that a data or the pieces of segments are received, it is being acknowledged. If it is corrupted, it has not been received, so expected that the source will not receive any acknowledgement, and what the source will do is to retransmit. And then there's that sequence number added on the uh, segments to identify the order of the segments. Okay, and in effect, data is sent at an efficient rate acceptable by the receiver. Okay, this is what we call as flow control. We'll discuss this later. Okay. For user datagram protocol, it's considered connectionless. When we say connectionless, the sender, here the sender do not know if indeed it is connected to the receiver. Okay? It will take its chance. Okay? There. It's like, for example, like in the movies, you go to a place and you don't know, example, your girlfriend or your boyfriend. Okay, the usual story, you go to Dubai and then you are looking for your girlfriend or boyfriend and you don't know if they're still alive. Okay? And you don't know if you're still connected with them. Ba? Because sometimes we look for that closure. Okay? I think that's acceptable analogy. So there, that's UDP. You go to the place and um, hoping you are still connected with that person. It's still alive. There's still an established relationship. Same thing here. With UTP is it goes to this FTP, okay, but it doesn't know if they are if this sender is connected. They still have an established connection. It has an established connection with the destination. Like in this case, the FTP server. So it will try its best. Okay, that's why it's called as best effort. Okay, in delivering the uh, pieces of segments. There's no acknowledgement. Okay, in the data. There's also no sequence number in UDP, in the user datagram protocol. The good thing with user datagram protocol is that it's faster as compared to TCP, but because there's little overhead, okay, and there's no acknowledgement, there's no idle time. So we'll focus first on the sorry, before we focus on the TCP, I have here an overview. I have here a summary of those characteristics that UDP and TCP has. And then another important thing to take note is that I mentioned this a while ago that there are a series of applications that uses TCP and there are those that uses UDP. We will explore on this later.